Okay, this is review number 5 on properties of circles. The first part, we're talking about tangents. Remember, a tangent and a radius, they're going to be perpendicular. That means it's going to form a 90-degree angle. And don't forget, a lot of these problems, in any circle, the radius length is always going to be the same in a particular circle. Okay, so on the first one it says find the value of x. Well, you have this exterior point right here, and this exterior point forms two tangents with SR and ST. Remember, a tangent, it's going to touch that, it's going to be a line or a segment that's going to touch the circle once. Okay, so there's a theorem that says within any exterior point that is tangent with the circle, those segments are going to be congruent. So you know that 3x plus 3 is congruent to 24. Since it's congruent, set it equal to each other. So 3x plus 3 equals 24. Okay, I'm going to subtract 3 on both sides. So we have 3x equals 21. And divide by 3 on both sides, and you're going to get x equals 7. Now make sure when you're going over your test that it's asking, or make sure you know what the question's asking for. This one says find the value of x, so we are good. We found x. We don't have to go back and plug anything in. Okay, on number 2, it says find the value of x again. Remember, all radius are going to be the same length in a circle. So if this radius right here is x, then that is x. Okay, so it's also tangent. We have, if it's tangent, it's going to be 90 degrees. So what you have is a right triangle. Okay, you're given two sides, you're trying to find the third. So you have a squared plus b squared equals c squared. Remember, your hypotenuse is always by itself. So you have x squared plus 12 squared equals 15 squared. Okay, then you want to simplify that. So you have x squared, I'm just going to square my numbers. 12 squared is 144 equals 15 squared. If you put that in your calculator, you're going to get 225. Okay, next I'm going to subtract 144 on both sides. Okay, and if you do that and subtract 144, you're going to get x squared equals 81. Okay, you don't want x, you don't want x squared, I'm sorry, you want x. So to undo something that's squared, take the square root. Well, the square root of 81 is 9. So that's telling me that this length is 9 right here, and that little length right there is also 9 because they are both radiuses, or radii. Okay, let's scroll. I'm going to do number 3 as well before I move the page. Alright, this is the one where all radii have the same value. So if this length is 8 right here, that's a radius. Well, this is also a radius, so that length is also 8. If that length is 8, what is this whole distance right there? Well, you're going to do just 8 plus 9. 8 plus 9 is 17. Okay, so now you have that whole distance. Again, this is tangent. Let me get a different color. So that's tangent. So again, I have a squared plus b squared equals c squared triangle. So when you set that up, we're going to have 8 squared plus x squared equals, now you're not just going to do 9 squared. This little part right here is not the hypotenuse. This whole length is the hypotenuse, so the whole length is really 17. So equals 17 squared. Okay, you want to simplify that, so write out what your values are. So 8 squared is 8 times 8 is 64, plus x squared equals, and then if you have 17 squared, that's 289. Okay, you're solving for x, so you want to get rid of a positive 64. Okay, so if you subtract 64 on both sides, you get x squared equals, and then 289 minus 64 is 225. Okay, you want to solve for x, so take the square root of that value. So if you do the square root of 225, you will get x equals 15, so x is 15. Okay, number 4 is the same type of problem. It's asking to find the value of x. You can't forget that tangent, so I know this segment right here is tangent. It's going to touch our circle once, and it's going to touch it at this point. So this right here, where the red dot is the point of tangency. There's a theorem, and it's going to say that it makes a 90-degree angle. It's perpendicular, so you have a right triangle. So now I have a squared plus b squared equals c squared. You know, this length right here is 21. That's a radius. You're looking for x. You have to know this side. Well, I only know this little part is 8. But remember, all radii are the same length. So if this is 21 right here, if that's a radius, then this is also the radius. Remember, the radius goes from the center to an edge. So that little part right there is also 21. Okay, so that's telling me this little part is 21 and that part is 8. So the whole distance is 29. So now I can do a squared plus b squared equals c squared, and the whole length is 29. So if I set that up, I have a squared plus b squared equals 29 squared. Okay, so if you're going to do 21 squared, you get 441 plus x squared equals, and then 29 squared is 841. Okay, you're solving for x, so we're going to subtract 441 on both sides. So I have x squared equals, and 841 minus 441 is going to be 400. Okay, you're looking for x, so you have to undo something that's squared. Oh, sorry, that's supposed to be a 400. So when you take the square root of 400, you're going to get 20, so you know this length right here is then 20. Okay, number 5, it says find the perimeter of the quadrilateral. Okay, so we just talked about if you have an exterior point, so for example, let's take this exterior point right here, and you have a tangent to both circles, it's going to be congruent. That's like our example on problem 1. So if one side is 3, the other side is 3, so we're just going to label our picture going around. Okay, if one side is 4, the other side is 4. If one side is 2 right here, this little side right there is also 2. And same thing, if you have one side is 1, the other side is 1. So now you can find the perimeter. You're just going to add all of these numbers up. So you have 3 plus 3 is 6, plus 4 is 10, plus 4 more is 14, 15, 16, 17, 18, 19, 20. So your perimeter is 20. Alright, I didn't mean to write 20 there. I meant to write 20 here. So I'm going to erase, well, I was going to erase this part. Alright, on number 6, it says BA and BC are tangents to circle O, so you know those are going to form 90-degree angles. So let's label that. So BA is a tangent and BC is a tangent. Well, the point of tangent is A and C, so I know it's going to form 90-degree angles there. Okay, label your picture. It says AB is 4x plus 2. Then it told me from O to B is 26. And then it told me C to B is 18. It's wanting me to find x. Well, there is a part of this is extra information. So you have this exterior point, and the two tangents that it makes with the circle is from B to A and B to C. So these parts are congruent. 26 has nothing to do with this problem. It's extra information. Okay, so you know that these two segments are congruent. So you're going to set those equal to each other. So we have 4x plus 2 equals 18. Okay, subtract 2 on both sides. And then when you divide by 4, you're going to get x equals 16 divided by 4 is 4. Okay, on the second part, we're talking about arcs and central angles. It says using the figure below, find the measure of each of the following arcs and classify them. So it's coming from the center right here. So remember, if it comes from the central, if it's a central angle, the arc is going to be the exact same. So once we find the arc, the angle is going to be the same. Okay, well, it gave us all parts of the different lengths that this circle has. A circle has 100 or 360 degrees. So what we're going to do to first we got to find x, because then we can go back and plug x in. So to find x, a circle has 360 degrees. So add everything up, set it equal to 360. So I have 4x plus 3x plus x plus x. So 4 plus 3 is 7. Right here is 8. And this is 9, 10. So I have 10x. Okay, then I have a 12 and a minus 2. So that'll take me to a positive 10. I'm going to set that equal to 360 because a circle has 360 degrees. Okay, so I'm going to solve this for x first. So I'm going to subtract 10 on both sides. So I have 10x equals 350. And that's an x, sorry. And when I divide by 10 on both sides, I'm going to get x equals 35. Oh, I didn't really fit that in. All right, x equals 35. Okay, once you found x, you're going to have to go back and plug it into each of these things to find the different measures. Okay, so I'm going to plug it in. I'm just going to go around a circle. So if I have 2 times 35, 2 times 35 is 70, so this AB is going to be 70. Okay, if I plug it in here, 35 plus 12 is 47. Okay, 35 times 3 is 108. 105. And then if I do 35 times 4 and I subtract 2, that's going to be 138. Okay, so now I have all my different arcs, so I'm going to go and figure out the degree, and remember if it's a major, minor, or semicircle. So if it is less than 180 degrees, it's a minor arc. If it's more than 180 degrees, it's a major, and if it is 180 degrees, it's a semicircle. So first thing I'm looking for is AC. So start at A, go all the way to C. So you're really just adding two different values up. I'm adding 70 and 47. So that degree, 70 plus 47, is 117. So my degrees are 117. Since this is less than 180, it is a minor arc. Okay, on the second one. Okay, the second one is from B to C. So BC right here is just 47 degrees. Since it's less than 180, it's a minor arc. Oh my gosh, that was terrible. Okay. Okay, on number 9, it's looking for from C to D. Well, that's 105 degrees. Since it's less than 180, it's a minor arc. Okay, and the last one, it says it wants us to go from A to D to C. So really, I'm adding 138 plus 105. So if I do 138 plus 105, I'm going to get 243. Since this is bigger than 180, this is going to be a major arc. Okay, on the next one it says find the indicated measure of each of the following. So it says in circle X, we're looking for the measure of EMA. Well, X is the center. How do I know that? Because you always name a circle by the center. That is your center X. So if I know that angle right here is 90, it's a central angle. It's coming from the circle or the center. So I know the arc length is the same. So I know this is 90. Okay, what am I looking for? I'm looking for from E to M to A. So pretty much I'm looking for the outer part, everything but that 90 degrees. Well, a circle is 360 degrees. I don't want to add in that 90, so I'm going to subtract 360 from that. And if you do 360 minus 90 to find the leftover missing arc, you're going to get 270. You have to know that little symbol means 90 degrees. Okay, on the next one it says in circle Y, RS and RD are congruent. Those are different arcs. So I have RS right here and RD are congruent, so I'm going to mark that. Congruent means the same. It tells me that RS is 95. So if RS is 95 and they're congruent, you know RD also has to be 95. We're looking for the measure of SD. Well, I know from here to here is 95 and here to here is 95. So what is that together? 95 plus 95 is 190. So really that whole arc in blue, I'm going to outline in blue, is 190. Well, it's a circle. You're looking for the leftover piece. Okay, you're looking for this piece right here. You're looking for the measure of SD. It's a circle. So circle's 360 degrees. We're going to subtract off 190, which is in blue. And if you do 360 minus 190, you're going to get 170. So SD, the missing part in red, is 170. Okay, on 13, it says find the measure of angle ETD. Okay, it's a circle. If you look at your picture, it's giving you all these different central angles. A circle is 360 degrees, so we're going to add everything up, set it equal to 360, and we're going to get x first, and then we'll go back. Okay, so I'm going to add, let's see what I have. I have 4x plus 4x plus 2x, which is 6. There's 7, 8, and there's 9, so there's 9x total. Okay, then I have a 12 and a minus 3, so 12 minus 3. Let me make sure that's a positive 12. Yeah, it is. Okay, so 12 minus 3 is 9, and then you're going to add 1, which gives you 10, and then you're going to subtract 1, that takes you back to 9. So 9x plus 9. It's a circle. A circle has 360 degrees. We're going to solve this first. Okay, we're solving this for x. So if you want to pause your video, solve this, find x, and plug it back in, and then replay it, go for it. Divide by 9 on both sides, so 351 divided by 9 is going to be 39, so x equals 39. That's not your answer. What is it asking for? ETD. So follow with your pencil from E to T to D. Since it's a central angle, you're just going to plug it into that value right there. So we're really plugging it in. I erased it so I could see it. To 2x plus 1. So we have 2 times 39 plus 1. And that's going to give us a total of 79 degrees. Okay, on 14, we're talking about, we went to part 3, arcs and chords. It says find the indicated measure. On this one, there is a theorem. It says in a circle, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So you're looking for minor arcs, so minor is less than 180. I see 2 minor arcs that are congruent. I have 98 and 98 here. So I know those 2 arcs are congruent. I know these 2 arcs are congruent. If I know those 2 arcs are congruent, then I know their chords are also congruent. So if they're congruent, I'm going to set them equal to each other. So I have 2x plus 8 equals 46. Okay, why am I setting these equal to each other? Because you have 2 arcs that are the same. That means their corresponding chords, which make up this red line that I'm outlining, are also the same. So we're going to solve this. So I'm going to subtract 8 on both sides. Okay, make sure you look over all of your theorems for your test. So 46 minus 48 is going to give you 38. Okay, divide by 2 on both sides, and you're going to get x equals 19. Okay, make sure it's asking for x, and this problem is. Okay, on number 15, it says, we're going to have to label our picture. It says PO is 12. And then it says NO is 20. Okay, if you're looking at NO, this goes from the center to an edge, part of the circumference of the circle, so a point on the circumference. This is your diameter. So all diameters in this circle are the same. It doesn't matter where your diameter or where your point is on the circumference. In this specific circle, since this radius is 20 right here, that means all of the radii are going to be 20. Okay, first thing it's asking for PN. Well, PN is right here. If you look right at your triangle, you have an A squared plus B squared equals C squared. So you have a mini right triangle in here. So you're looking for this length right there, X. So we're going to do X squared plus 12 squared equals 20 squared. So you have X squared plus 144 equals 400. Okay, when you solve for X, you're going to subtract 144 on both sides first. So you have X squared equals 256. Okay, you want to take the square root of that value. You're solving for X. So if you take the square root of that, you're going to get X equals 16. So you know, I'm going to go back and I'm going to erase that. So you know PN is 16. Okay, well then it's looking for M to P. So now I know from P to N is 16. Now I'm looking for from M to P. Okay, there's also a theorem and it says in a circle, if the diameter or radius is perpendicular to the chord, which ours is, we have our radius, it is perpendicular to this chord. Perpendicular means it forms a 90-degree angle. Then it bisects the chord and its arc. That means the radius is going to bisect the chord. Well, if it bisects the chord, what does that mean? Bisect means cut in half. So if this little part is 16 right here, what does that make MP? 16. So I know MP is 16. Okay, then you're looking for LP. Well, we already discussed that from L to O is a radius. It goes from the center to a part of the circumference, a point on the circumference of the circle. Okay, so this whole length is 20. Well, I already know this little part is 12 right here. So to find the next missing part, we're going to do 20 minus 12, and that's going to be 8. Okay, and the last thing we're looking for is M to N. M to N is this whole length. Well, I already know this is 16 and that's 16. So if I add those up, I'm going to get 32. Okay, 16 deals with another theorem. I know that NL is 9, so this chord is 9. So I'm thinking of different theorems that it's talking about chords, and I'm looking for M to P. Okay, if you look at your circle, you have your center, and you know that these two segments are congruent. How do you know they're congruent? Because you have that little tick mark. Okay, so there is a theorem that it says in a circle, two chords are congruent if and only if they are equal distance from the center. Well, I have two chords. I have this one in purple right here and this one in red. Are those the same distance from this center? Well, yes, because I have a tick mark right there and I have a tick mark right here. So I know that they are the same distance. If they're the same distance, it told me that those chords are congruent. So if N to L is 9, then M to P is also 9. Okay, on 17, you are given two segments that are inside the circle. So remember, the product of the lengths of the two segments from the point on the circle is constant along any line through the point and the circle. So this was in your notes. You're going to have to figure out what circle you're working with, match it up with a picture, and you're just going to follow the formula. So this one, you're really just multiplying part of the segment or part of the chord times the other part of the chord equals multiplying the two numbers going the other way. So we have x times 10, or I can just do 10x, equals 5 times 6. 5 times 6 is 30. Then you're going to solve that for x, and just divide by 10 on both sides, and you're going to get x equals 3. Okay, same thing with number 18. If you're following that formula, it's telling you, so since the top arc, or the top segment, goes through the circle, so what we're going to do is we're going to add the two numbers first. So I'm going to add 10 plus 8. And then the formula tells me to multiply by the part that's outside the circle. Well, 8 is outside the circle, so I'm going to multiply that sum by 8. Okay, now if you look at the bottom part, it's only tangent to the circle from the exterior point. So since it does not go through the circle, you're just going to take this value and square it. So this squared, or y times y, is just y squared. And that is your formula that we're going to use. Okay, so I'm going to add these first. So I have 10 plus 8 is going to be 18. So it's really 8 times 18 equals y squared. And 8 times 18 is 144. So I really have 144 equals y squared. Okay, you don't want y squared, you want y. When you take the square root of 144 in your calculator, you're going to get 12. Okay, on number 19, you have another circle, and it says if AC is 13 and CD is 5, then find A to B. So let's label our picture. If AC is 13 and C to D is 5, then I'm looking for A to B. I'm looking for this whole length. Well, if you look right here, you have a right triangle. Pythagorean theorem is going to play a lot in this unit. So first we got to look for this missing part, because remember that theorem that says if a chord is intersected with the radius and it's perpendicular, then it's going to cut the chord in half. Well, here's our radius, here's our chord. They're perpendicular and they intersect. So I know whatever A to D is, that means D to B is the same thing, because it's going to bisect. Bisect means cut in half. So I'm looking for this missing blank right here. I have a 5 blank 13 triangle. This is a triple. Okay, it's 5, 12, 13. So that blank is really a 13. So if this part is 12, then D to B is also 12, and you're looking, the problem asks for AB, so we're looking for this whole distance, and 12 plus 12 is 24. Okay, on number 20, we're going to work with arc length and sector area. We're going to need some space, so make sure you're writing small, because we're going to set up two different proportions. So to find arc length, we're going to use circumference. So we're going to first find the circumference, so that's what C is going to equal over here. Circumference is really just 2 pi r, or you could do pi d. Well, what is your radius? Our radius is going to be 4. So 4 is really r. 4 times 2 is 8. So my circumference is 8 pi. Okay, I also need my area. Your area formula is pi r squared. So take your radius, which is 4, square it. 4 squared is 16. So your area is really 16 pi. Okay, once you know that, we're looking for the shaded area and the shaded arc length. So we're going to use that formula that's in your notes, that proportion. Okay, so let's do arc length first. Since we're doing arc length, we're going to be looking for the length. And since it's part of the length, it's really your whole circumference. So when we talk about length, we're really talking about circumference. So we're going to use our circumference, which is 8 pi, equals the number of degrees that we're working with, 120, over the total 360 degrees. Cross multiply, so 360 times x is 360x. Okay, when you multiply going the other way, you're just going to multiply your numbers and then keep pi for the end. So 8 times 120 is 960 pi. So divide by 360 on both sides. Okay, you're going to get 2.6666 repeating. Do math, enter to get a decimal, or to get a fraction. and you're going to get 8 over 3 pi. If you were to put that in your calculator, 8 divided by 3 times pi, you would get an equivalence of 8.38. Okay, so either answer will work. Just tomorrow on your test, if it's multiple choice, look to see if your answers are in pi or your answers are rounded. Okay, to find sector area, we're going to use the area, which is 16 pi. So we're going to do the sector area, which we're looking for, divided by the area of the circle, equals the number of degrees that we're working with, over the total number of degrees, 360. Again, cross multiply and solve. So 360x equals, now I'm going to multiply 12 times 120, or I'm sorry, 16 times 120. And I'm going to get 1920, don't forget pi. Okay, divide by 360 on both sides. Okay, you're going to get 5.333 repeating, do math, enter, enter. And you're going to get 16 over 3 pi. Or if you want to do that as a decimal as well, if you're rounding, if you want to multiply pi in, it's going to be 16.76. Okay, on 21, we're going to do the same thing. We are looking for the shaded area of our circle, so A, B to C. How do I know that? If you look right here, this is also A, B, C. So from A to B to C. Since arc length is dealing with a part of the circumference, we're going to have to find the circumference first. So let's do that. So the circumference is really 2 pi r. Or you could do pi d. Same thing. Your radius is 8. If your radius is 8, okay, 2 times 8 is 16, so your circumference is 16 pi. Okay, let's set up that proportion first. So to find arc length, we're going to do x divided by, because we want arc length. We don't know what that is yet, so that is our variable. X divided by the circumference, which is 16 pi, equals the number of degrees we're working with. So if we know this little part is 45 degrees and it's a central angle, we're looking for the other part. Well, it's a circle, so let's do 360 minus 45 to find the number of degrees that we're using. So that's going to be 315 degrees. So we're going to make our proportions. So the 315 degrees we're using over the 360 degrees total of a circle. So cross multiply. So I have 360x equals, go the other way. So we're going to keep pi on until the end. So I'm going to do 16 times 315. It's going to be a big number. That's fine. So I have 50, 40. Don't forget pi. Now tack on pi at the end. Okay, solve for x. We're going to divide by 360 on both sides. And I'm going to get 14, and don't forget pi. So your area length, your arc length is 14 pi, or if you were going to round it, you should get 43.98. Okay, for sector area, you're finding area, or you need area of this circle, so we're going to find that first. So area is pi r squared. Well, your radius is 8, so 8 squared is really 64, so it's 64 pi. So we're going to set up another proportion with that. So I have the sector area I'm looking for over the area of the circle equals the number of degrees that I'm working with, which is 315 still, divided by 360 total degrees of a circle. Cross multiply. We have 360x equals, go the other way, 64 times 315. And you get 20160 pi. Don't forget pi. I know I'm kind of running out of room. Divide by 360 on both sides. Okay, and you should get x equals, when you divide that, you should get x equals 56, and don't forget pi. So that is your answer, that's your answer as exact. If you wanted to round that, you would get, and I am running out of room. Okay, if you were to round that, you would get 175.93. Okay, so make sure you know the difference between arc length and sector area. So arc length, think of it's part of the circumference, so you have to use circumference in your circle. And sector area is part of the area, so you're going to have to use the area of the circle in part of your proportion. Okay, 22, it's asking, it says in a circle with a radius of 15, that's probably important information, I'm going to underline that. The measure of an arc is 150 degrees. Find the length of the arc. So really we're using arc length again. We're just going to plug it into our formula. Remember, it's the arc length over the circumference equals the number of degrees that you're using over 360 degrees. So the arc length, I don't know what that is. Okay, I need to put it over the circumference. Circumference, remember, is always 2 pi r. Or pi times d. Well, I know my radius is 15. If my radius is 15, 15 times 2 is 30. So my circumference is really 30 pi. Okay, equals the number of degrees I'm using. It says the measure of an arc is 150 degrees. So I'm using 150 divided by the total number of degrees of a circle is 360. So here we go, cross multiply. So I have 360x equals 150 times 30 is 4,500. Don't forget pi. Divide both sides by 360. And you're going to get 12.5 pi. So you could have 12.5 pi, or if you plug that into your calculator, 12.5 times pi, and you want a rounded answer, you're going to get 39.27. Okay, remember, so if you have pi in your answer, that's exact. If you round it, if you type this into your calculator and press enter and you use pi, this is going to be a rounded answer. Okay, on number 23, it's looking for sector area, so that means I know I'm going to need area of a circle. Okay, it says in a circle with a radius of 6, that's probably important information. The measure of the sector area is 120. We want to find the sector area. So I have to set up my proportion for sector area. I have to find the area of the circle first. Well, area is always pi r squared. So if you plug that in, well, what is your radius? It told you your radius was 6. So 6 squared is 36. And don't forget pi. So we're going to do x divided by the area of the circle, which is 36 pi we just found, equals the number of degrees that we're using, which is 120, divided by 360. Okay, cross multiply. 360 times x equals, go the other way, 36 times 120, and then just add pi on at the end. 4320 pi. Okay, last step, divide both sides by 360. And you're going to get 12 pi. So the sector area is 12 pi. If you wanted it as rounded, you would multiply, type that in your calculator, press enter, and you would, since it comes out to 37.699, you would round that up to 37.70. Okay, the last one deals with sector area before we move to converting degrees to radians. It says a pizza with a 12-inch diameter is cut into 10 equal slices. Find the approximate area of only one slice. So we're talking about area sector again. So I'm going to need area of my circle. I know that. So area, remember, is pi r squared. Now, if it's a 12-inch diameter, what does that make r? Well, diameter is the whole way. Radius is half. So if the whole distance is 12, half of that has to be 6. So your radius is 6. So my area, again on this one, 6 times 6 is 36, so you have 36 pi. It says cut into 10 equal slices. So if you're cutting it into 10 equal slices, it's a circle. A circle has 360 degrees. Well, if you want to split up 360 degrees evenly between 10 slices, divide it by 10. So that's telling you that each slice, if you divide that, is going to be really 36 degrees. So this is the number of degrees that we're working with for one slice, because remember, it's asking only for one slice. So we're using our area and 36 degrees for that proportion. So we don't know the area of one slice. We're looking for that, but I do know the area of my circle is 36 pi. The degrees that I'm working with is 36, and divided by 360 degrees total of a circle, cross multiply. So 360 times x is 360x equals 36 times 36 is 1296. Don't forget pi. Divide both sides by 360. And you're going to get 3.6 pi. But it says find the approximate, so we're going to have to type 3.6 times pi in our calculator. Remember, to get pi, you're going to do second and then the little caret symbol that looks like this. Okay, so if I do 3.6 times pi, you're going to get 11.31. Okay, if it was multiple choice, you would have to look at your answer choices to see how many places to round to. Okay, these first four problems, it says convert the following degrees to radians. So if you're using the formula, so the formula to convert degrees to radians is to multiply by pi divided by 180. So we're going to do that for all of these. So I have 120. I'm going to multiply this by pi divided by 180. Okay, I'm multiplying, so I'm gonna still put that over 1, but when you multiply straight across. You're going to do 20 times pi, which is just 20 pi, divided by 1 times 180 is 180. Okay, you're going to have to simplify this fraction. So 20 divided by 180, put that in your calculator. You're going to get a decimal, do math, enter, enter, and you're going to get 1 over 9. Okay, so if you have 1 over 9 and you still need pi, that 1 really isn't necessary because I'm going to put a pi there. So I'm going to change that and I'm going to make it a pi. Because remember, there's really like an imaginary 1 right there to tell you that it's 1 pi. So your answer is pi over 9. Okay, on 26, same thing. Multiply by pi divided by 180. I'm going to still put 90 over 1 so I can multiply straight across. So 90 times pi is 90 pi. Divided by 1 times 180 is just 180. Okay, we still can simplify. We're going to simplify the fraction. So I'm going to do 90 divided by 180 in my calculator. Math, enter, enter. It's 1/2 again. So your numerator is 1, but don't forget you have to keep that pi there. So it's really just pi divided by 2. Because remember, there's an imaginary 1 right there. Okay, on 27 again. Pi divided by 180. I'm going to put this over 1. So I have multiply straight across. 180 times pi is 180 pi. Divided by 1 times 180 is 180. Okay, well, if you have 180, those are going to cancel. And what are you going to be left with? You're going to be left with pi. So this answer in radical form is just pi. You can have just pi. That's fine. Okay, on 45, we're going to multiply by pi divided by 180. Put that over 1, multiply straight across. 45 times pi is 45 pi. Divided by 1 times 180 is 180. Okay, simplify your fraction. 45 divided by 180, math, enter, enter. Okay, it comes out to 1 over 4. Don't forget, you have to put pi in your answer. So pi is your numerator divided by 4. And there you go. Okay, now we're going to convert on the next page. We're going to start with radians and we're going to convert to degrees. Okay, so if we're starting with radians and we're going to degrees, we're just going to flip our fraction. We're going to multiply by 180 divided by pi to each thing. Remember, our pi's are probably going to cancel. So I'm going to multiply 29. I'm going to do multiply by 180 divided by pi. Okay, well, luckily enough, my pi's are going to cancel, which is good. I'm going to still multiply straight across first. So I have 4 times 180. And that's going to be, oh, that's not an equal sign. 720 divided by, and then on the bottom I'm just left with 3. So 720 divided by 3. And that's going to be 240 degrees. Okay, on 30, same thing. I'm going to multiply by 180 divided by pi. Okay, our pi's are going to cancel, which is good. Okay, when I simplify that, when it cancels, it really changes into a 1. So I really have 180 on top divided by 2 on bottom, and 180 divided by 2 is 90, so 90 degrees. 31, same thing. You're changing from radians to degrees. So to do that, you're going to multiply by 180 divided by pi. Okay, the pi's are going to cancel. Multiply straight across. 5 times 180 is 900 divided by 6. And 900 divided by 6 is 150. So you have 150 degrees. And for the last one, same thing. You're converting radians to degrees. So multiply by 180 divided by pi. So you can put this 2 pi over 1. Your pi's are going to cancel again. So those go away. So 2 times 180 is 360. And on the bottom you only have 1. Well, 360 divided by 1 is 360. So 2 pi is really 360 degrees. Okay, so for 33 and 34, it says write the equation of the following circles in standard form. So remember, the first part of your equation comes from the ordered pairs of your center, and it's going to equal your radius squared. So we need two things. We need to find our center, and then we need to find what the length of our radius is. Well, our center is right here, and this is positive 1, positive 2, positive 3, and then how much do I go down? 1, 2, 3, 4. So my ordered pair is 3, negative 4. Okay, remember your radius is the same distance from the center to an edge of the circle. So I just go north, east, south, and west. So if I go up, it's 2. If I go left or right, it's 2. If I go down, it's 2. 2 places over, and if I go left, it's 2 places over. So I know my radius is 2. So remember the equation is going to be x squared plus y squared equals r squared. That's it. That is if it's at the center. Now, if it's not at the center, it's going to be your equation is going to be a little different. So if it's not at the center, you're going to do x minus your x value squared plus y minus your y value squared equals your radius squared. Okay, so in parentheses, I'm going to do x minus my x value is 3 squared plus y minus. Now, my y value is negative 4, so when I put a minus and a negative right next to each other, it's going to change to a positive 4 squared equals. Now take your radius squared. 2 times 2 is 4. So that is your equation. Okay, 34, same thing. We need to get our center. And we need to get our radius first. So our center is right here. You're not going left or right. So your x is 0 and you go down 4. So it's a y-intercept. So it's 0, 4. Or I'm sorry, 0, negative 4. And then your radius, remember, just count the distance going up or left, right, or up, down, left, or right to find your radius length. So we're up 1, 2, 3. does that match going around 1, 2, 3? Does it match going down 1, 2, 3, and to the left 1, 2, 3? Yes, it does. So I know my radius is 3. Okay, so since I don't have a value, since my x is 0, you're going to start your equation off with just x squared, because x minus 0 is just x. So I have x squared plus now, but my y has a value, so I'm going to have to open up parentheses. So I have y minus, again, you have a negative value. So when you have a minus sign and change to and put a negative right next to it, it's going to change to a positive because two negatives make a positive. Equals, and then you have your radius, take that and square it. 3 times 3 is 9, and then that's your answer. Okay, these last couple, we're just going to find the value of the variable with our different circles. So on 35, this is a central angle. How do I know that? Because it comes from the center. That dot there is the center. So the center, if it's a central angle, the angle is the same length as the arc. So I know these two are equal. So I'm going to just set them equal to each other. So I have 3x plus 6 equals 84. Subtract 6 on both sides. So you have 3x equals an 84 minus 6 is 78. Divide by 3 on both sides and you're going to get 26. Okay, on 36, there is a theorem and it says if a quadrilateral is inscribed in a circle, which ours is, then its opposite angles are supplementary. Supplementary means they equal 180 degrees. So you're going to find opposite angles and you're just going to set them equal to 180. Or they have to add to 180. So if this is 120, the opposite angle is y. Those have to be 180. If you do 180 minus 120, you're going to get 60. Same thing with the x's. Opposite angles are supplementary. So this right here, those are opposite angles. If this is 50, your other angle is 130. They have to add to equal 180. 37, same thing. You have a quadrilateral. Quadrilaterals is four-sided figure. Since it has four sides, opposite angles are opposite angles are supplementary. Supplementary means it equals 180. So do 180 minus 113 to find that missing angle, and you're going to get 67. Okay, on number 38, this is an inch or a different type of angle. Okay, so it's an angle in an inscribed circle, but the main point right here is on the part of the circumference. Okay, so it says if an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. So this angle it's going to be half of this intercepted arc. So when we set that up, we're going to do the angle, which is x plus 30. That has to be 1/2 of this arc. Well, what is that arc? That arc is 4x. So I have x plus 30 is 1/2 of 4x. Well, what's 1/2 of 4 is 2, so it's 2x. So I'm going to subtract x on both sides, and I'm going to get 30 equals x. So this value of x is 30. Okay, on 39, again, you have a central angle. So since you have a central angle, the arc value is going to be the same. So I'm going to set them equal to each other. So I have 3x minus 8 equals 70. Add 8 to both sides. So you have 3x equals 78. And when you do 78 divided by 3, you're going to get x equals 26. Okay, on 40, if you have two arcs, or if you have two chords that are going to intersect on the inside of the circle, if you have two secants that are going to intersect on the interior of the circle, so just on the inside, the angle that's formed right here is going to be half of the sum of the two measures of the arcs that it's intercepted by. Okay? So really what you're going to do is you're going to take your angle. So your angle equals just 1/2 of what those two values added are. Okay, so since it intersects in the middle of the circle, you're going to add your values. So 140 plus 40, and then divide by 2. Okay, so 140 plus 40 is 180. 180 divided by 2 is 90. Okay, and then the 41, there's a theorem that says if two secants and a secant and a tangent, or two tangents intersect on the exterior, which it does, these two secants intersect on the exterior, then the measure of this angle is half of the positive value. So we're going to, or half of the positive difference. So we're going to do big minus small and then divide by 2 to find that missing angle. So I'm going to do x equals 1/2 of big, which is 95, minus small, which is 25. Okay, 95 minus 25 is 70. And 1/2 of 70 is 35 degrees. Okay, 42 is similar to 38 up here. It's the same type of problem. So your angle is going to equal 1/2 of the arc. So our angle of 20 equals 1/2 of our arc. What is our arc? Our arc is 4x. So I have 20 equals 1/2 of 4x is 2x. And when I divide by 2 on both sides, I'm going to get x equals 10. Okay, so this is the end of the review. If you need to re-watch different parts or different problems, make sure you do that. Make sure you go over all of your theorems as well and the different proportions that you need or what you need to change from radians to degrees, all that good stuff. So look over your theorems, look over the formulas that you need, and you should be set. Good luck.